It's good now. Okay. So this is a pre-prep live evaluation and mentorship session. Now the question here is discuss the concept of volcanicity and show how the theory of plate tectonics explain the mechanism of volcanism and volcanic eruption. So here we'll be seeing that we have two very separate phenomena here. Number one with the volcanicity and number two its interlinkage with the plate tectonics. Now let's understand this answer first, then we'll be looking at the approach which can be applied here. So the plate tectonics theory being scientific. Okay, so instead of scientific, we can write here positivistic, because positivistic is something which is related to the scientific phenomena and its application in geography. Okay, in nature, not only explains the mountains, but also the mechanism of volcanism and volcanic eruption as well. Okay, so here we need to also address the name of the theorist. We should address actually Morgan, like Morgan, Mackenzie, Wilson, Parker. Okay, so they have only given this the volcanism, the concept of volcanism under the plate tectonic theory. So if we look at the concept of volcanicity, so volcanicity is a what this is written process. Okay, this is a process in which molten rock, gases, and other materials come out from the interior of the earth. Okay, so this is very good. This is well written. It encompasses intrusive and extrusive activities. Okay, this is also well explained. Subduction of plates deep inside the crust causes the plate to melt, and molten magma tries to escape through the volcanoes. Okay, so this is also very well explained. Okay, here we are seeing the intrusive rocks as well as the extrusive rocks. So extrusive rocks, we can name them as volcanic mountains. This is lava plateau. This is batholith. This is, we can say here, sill. This is dike. Okay, this is lopolith, etc. We can also add laccolith and other features here. Okay, now plate tectonics theory and the mechanism of volcanism. So plate tectonics theory explains the mechanism of volcanism through the different plate boundaries. Okay, so here okay, we are talking about different plate boundaries. Different plate boundaries, ascending limbs of convection current. Okay, for example, the ascending limb of the convection current causes the drift in the plates. Okay, it causes the drifting of plate here. Okay, so we can also explain this with the diagram. Drifting away of the plate gives place for the magma to come out, which ultimately leads to the formation of mid-oceanic ridges. Okay, this is also well explained. So here the magma is coming out and there is emplacement of magma and formation of mid-oceanic ridges. Okay, so well explained. Subduction causes the formation of trenches, which also gives place for magma to come out, causing the volcanism along the trenches. Along the trenches, there is no volcanism. Why? This is one plate. This is another plate. So here we see that there is accretionary wedge will be present here, but the presence of magma, it will be in this region. And it will not be present around the trenches. It can be present over the cracks and fractures. Which can result into the formation of volcanic mountains or plateaus or anything else. Okay. Yes, you have drawn it here. volcanism will not be present here, but it will be present over the continental crust. Okay, or it can also be oceanic crust, or we can in general say that non-subducting plate. So this is important to show here. Now, the formation of mid-oceanic ridges, okay, good. Formation of trenches giving rise to volcanism. Don't write this part here, okay, because the volcanism, it is happening because of the melting of the crust, okay, because of the presence of water, which is present with the plate, which is subsiding with the plate here, subducting with plate, and it is changing the composition. There is the chemical reactions because of the presence of water. So this is basically resulting into the formation of magma. Now, next is convergent plate boundary. Okay, I think this is also convergent plate boundary.
Wasn't I have also explained the trenches for boundary also. I drawn it here.
Your voice is not clear. You can type the message. You can type the message. Okay, so I was explaining the divergent plate boundary. But under the divergent plate boundary, there is no presence of trenches. Under the divergent plate boundary, there is, it can be either mid-oceanic ridge or it can be the rifting of the continent if it is present over the continent. The formation of trenches will always occur under the convergent plate boundary. Okay. Now, moving ahead, the convergent, the convectional current causes the plates to move towards each other. Okay. Movement of the plate causes subduction of denser plate deep inside the Earth's crust. Okay. The subduction causes the melting of the plate due to higher temperature. Okay. Along with water. The molten rock then come in the form of magma through the volcanoes. Okay. Over non-subducting plate. Okay, so this is explained here well. The plate tectonics and volcanic eruption. The magma generation due to the subduction may ascend due to buoyancy. Now, we have written this very good term here. But you also need to explain here that how this buoyancy is happening. Okay. Now, here we'll be seeing that or I can draw a bigger one. Okay, I'll take this area. Okay. Now, here we'll be seeing that inside the magma, there is one reaction is going on, which is called as Bowman's reaction series. Okay. Under this, what will happen here? For example, the plate is subducting and it is reaching up to almost the depth of 400 kilometers. Okay. Now here what will happen? Certain part of magma, it will melt. Okay. Now this magma which is melting here, it is almost melting at a temperature of 1100 degrees Celsius. So if we will look at the composition of this two part, so almost 35 part, it will be consisting of silica and the rest 65% of part, it will be consisting of the part of parent rock. And here we'll be seeing that it will undergo melting. Okay. And this rock, 65%, it will be ultramafic. Okay. It will be ultramafic. Now, what will happen in this particular aspect here? The lighter part, that is the 35% part, it is quite lighter. Therefore, it will become buoyant. Okay. It will try to move up. Now, it will be ascending, it will be intermixing with the other rocks here, where we'll be seeing that the silica, it will be 35% here again, and it will be silica here, and the rest of the part, it will be reducing. That is, here we have 65%, there will be reduction of this ultramafic rock, and it will become mafic rock. Okay. As it will ascend more, there will be again intermixing of the rock will take place, where we'll be seeing that the silica, which was initially 35 units, it will be again remaining same. And here the amount of the mafic rock, it will decline. Okay. And here it will become 20, and this composition, it will become a andesitic rock. Okay. It can be andesitic to also felsic. So because of this reaction series, okay, the magma is becoming buoyant and it is ascending. So if a question is here with respect to why it is ascending, so therefore we need to give the reason for the magma for ascending and its buoyancy nature. Okay, so this is, we have to also add this Bowman's reaction series here. Okay, then gas expansion increases the pressure. This is also correct. Then pressure exceeds, which causes the eruption. This is also very good. Such holistic explanation of not only mountains, but also the volcanoes and earthquakes give the global acceptance to the plate tectonic theory. This, we can say, conclusion is very good. But when we are talking about volcanicity, so we can also explain here one part, that is when there is a convergence, which can be oceanic convergence, this will result into volcanism. When there is oceanic continental convergence, it will result into volcanism. Number 3, there is continental convergence, there will be no volcanism will be present here. Number 2, divergence. Okay, under the divergence part, we will see here that, okay, here we can put up continental convergence as Himalayas. Okay, under the part of divergence, we have continental divergence. There is no volcanism. Okay, here we can write East African rift. Okay, which is taking place now. Oceanic divergence. This is resulting into mid-oceanic regions. Okay, this is also giving volcanism. Now, under the third part, the transform plate boundary. It is not resulting into volcanism. So if we also want to link it with the plate tectonics, okay, that is the phenomenon of convergence, divergence, and transform. So it is related with the oceanic continental convergence only, and not with continental convergence, neither with continental divergence. So this is also needed to be added here to make it more clear to the examiner that yes, we know in detail that how the convergence, divergence, and transform boundaries are related with the volcanism. Okay, then If we have time or if we have space, for example, if this question is for 20 marks, so we can also add up a map of the world where we can explain the presence of volcanism in different regions of the world. So here we have trenches. Here we have volcanism in this region. Here we have Atlantic, mid-oceanic Atlantic ridge. Then here we have volcanism in this region. Okay. In Himalayas, we do not have volcanism, but yes, we have volcanism at the, we can say the circum-Pacific zone and the island arcs region. Okay, so these are certain regions where we can associate the volcanic aspect. And one more thing, you can add up here the plate tectonics. Okay, you can write here. However, plate tectonics do not explain the volcanism due to mantle plum or mantle hotspot mechanism. So this will give your answer a better orientation that yes, you know when the volcanism is taking place and what is the limitation of the plate tectonic theory where it is not able to explain the volcanism when the mantle plum or the hotspot mechanism is occurring here. Okay. So are you able to get this question well? Any doubts here?
Yes, sir. No, sir, no.
Okay, so this is the second question for the discussion. So I think you might have got a very good orientation and insight also for how to make an approach for such kind of questions. Okay, so see you in the next session then, and all the best.
Thank you, sir.